Hi, this is Mr. Ward, and this is Algebra Do Now 27.1, and I'm going to go ahead and do a key for you here. So what does this equal? What does this even mean? You can choose more than one answer, and hint, hint, you can choose more than one answer. That is a hint that there is more than one answer. Well, this is the square root of 81, and what we're looking for are two numbers. Is the number that you would multiply by itself to get 81. Another way to think of it is, what are two equal factors of 81? So if we could split 81 into two equal factors, what would they be? Well, one of them, we could do 9 times 9, and that would work as two equal factors. However, so that's one of the answers. I'm going to go ahead and write this over here. However, so 9 is definitely one of the answers. So boom, cool. However, there's another answer. We could split 81 into -9 times -9, because -9 times -9 will equal the positive. It'll be positive 81 as well. And so 9 and -9 are our answers. So it turns out the square root of 81 has two answers. Now, oftentimes, when people ask you what's the square root of 81, they're really just asking for what's called the principal root. And the principal root is just the positive root. However, in reality, there are two roots, two square roots, two ways to answer this, a positive and a negative. And the fancy pants way to write it, and it's not that fancy, it's just fancy in that you don't have to write as much. You can just say plus or minus 9. And what that is saying, that's a way of, in a compact way, saying 9 and also -9. This is going to matter in the new unit, because we're going to find that you have more than one answer to an equation. So what does this equal? Okay, and just as in the last case, there were two answers, there's going to be two answers for this one as well. So we can split 49 into 7 times 7, but we could also split the square root of 49. You'll notice the square root symbol looks a lot like a long division symbol. Well, it's kind of a special case of division. It's a case of division where your divisor equals your quotient. So this is also going to be -7 times -7. Okay, that's the answer to that. So we can put in that our answer is 7 or -7. Both of those are answers. If you want to be fancy, you could say plus/- 7. And I would understand that you mean both +7 and -7. Those are not the same number. Those are two different numbers. Now let's take a look at this next one. We're going to open up Desmos, and we're going to graph these two equations. So y equals x minus 9 and y equals x times x minus 9. And I'm going to pause my video because that's my son at the doorbell. Okay, we're going to open up Desmos, and we're going to see what these are about. So we've got y equals x minus 9 and y equals x times x minus 9. Okay, and if you have a thought about what these might look like, that would be awesome to think about ahead of time. So here we go into Desmos. So we got y equals x minus 9. And that makes a nice little linear equation. There we go, y equals x minus 9. And it has a y-intercept at -9. Happens to have an x-intercept at 9, 0 as well. That's pretty cool. We're going to do the other one. Y equals x times x minus 9. Okay, now this one also has a y-intercept at -9. That's interesting to note. And then it also has two x-intercepts right here. We're going to click on them. I will in a second. But this is a parabola. This is a parabola. This is a common basic polynomial type of graph. This is the very basic type that's basically y equals x times x. Now, Well, isn't y equals x is just a linear equation, but now we're doing y equals x times x. What we've done here is we've actually multiplied linear equations. Two linear equations will end up making this. Okay, so I'm going to go ahead and note right here and right here are the x-intercepts. So these are when y equals 0, what is x? Well, x ends up being two things. The x-intercept is 3 and it's -3. And think about, what do those have to do with the number 9? Well, -3 times -3 would be 9. And 3 times 3 would also be 9. And this being a squaring function, if I took that -3 and I put it in here, I'd be doing -3 times -3. Okay, and then -3 times -3 is 9. Subtract 9, I end up back at 0. Same with 3 times 3. If I plugged in 3 for x, I get 3 times 3 minus 9. That'd be 9 minus 9, and I'd end up back at 0. Okay, there is a better way that we can express this, y equals x. And then here's how you do this on Desmos. There's a little button right over there. It's at the number 6. There's a little symbol, looks like a pointy hat, okay, from the pointy hat factory. And you hit Shift 6. And on Desmos, when you do Shift 6, instead of getting a pointy hat, you go up into exponent land. And I'm going to say squared. And then I move my arrow key over 1, and I say minus 9. And that is the same dang thing. That's the same equation. Now, this equation is the product of two linear equations. Okay, and we'll get in, there's some other ways that we can express that as the product of two linear equations. We'll get into that later. But right now, let's go back into the do now. And so what is different about the two graphs and what is the same? Well, what is different, x minus 9 is linear. X times x minus 9 is curved, specifically parabola. What's the same? They have the same y-intercept. Okay. Another thing that you might not have noticed being the same is they are both built out of linear equations. Okay, y equals x minus 9 is just one linear equation. Y equals x times x minus 9 is two linear equations multiplied times each other. So when we get into polynomials, a key idea is that polynomials are products of linear equations. Okay, let's take a look at this. Now, we just encountered this. What do you think x would equal in this equation? You know, and if you think there is more than one answer, say so. So x times x equals 9. Well, what times itself equals 9? Well, x could be 3 because 3 times 3 equals 9. And x could also equal -3 because -3 times -3 also equals 9. Negative times a negative is a positive. All right, I hope that helped. And welcome to some of the very beginning ideas of polynomials and quadratics.